In today's video, I'm going to be talking about SURDS, how to rationalize denominators. Let's say we are given a fraction 1 over root 3. This here is a non-rational denominator. Changing this to a rational denominator is what we call rationalization. It means we are going to get rid of this SURD here. But how do we rationalize? To rationalize, we multiply this by root 3, this root 3 here, then by root 3. Root 3 over root 3 is the same thing as 1. So it means we are not affecting this fraction here. So root 3 multiplied by 1 is root 3. Root 3 multiplied by root 3 is 3. So the square root of a number multiplied by itself is that number. Let's take another example. Let's say 2 over root 5 multiplied by 2 over root 5. 2 over root 5. Let's 2 over root 5 here. 2 over root 5. To rationalize this, we multiply by root 5. Then root 5 again. So this is 2 root 5 over root 5 multiplied by root 5 is 5. So let's step this up a little bit. Let's say, let me erase this. Let's say we have 2 over the cube root of 5. How do we rationalize this? So you should bear this in mind that this, the cube root of 5, is different from the square root of 5. So this cube root of 5 multiplied by itself is not going to give you 5. So what are we going to do to rationalize this denominator? The cube, if you have a cube root of 5 cube, this is going to give us 5. So is there any way to make the cube root of 5 equal to the cube root of 5 cube? Yeah, very possible. That is if we should multiply by the cube root of 5 squared. You were taught in basics that once you have x squared multiplied by x squared, s cube, you have x squared plus s raised to the power 2 plus 3, you add the powers, and you have x raised to the power 5. So here we have 5 raised to the power 1 multiplied by 5 raised to the power 2, would have 5 raised to the power 1 plus 2, and would have 5 raised to the power 3. So this shows us that this multiplied by this will give us this. So we multiply by 3 cube root of 5 square over cube root of 5 square. So rationalizing with this would have 2 multiplied by the cube root of 5 square is 25 over this multiplied by this is 5. So this is the solution to rationalizing this fraction here. Let's treat something similar again. We have 4 over the 5th root of 8. So what are we going to use to rationalize this? As I said earlier, 5, the 5th root of 8. If we should have a power of 5 here, we would have 8. So the 5th root of 8 multiplied with the 5th root of 8 raised to the power 4 would give us the 5th root of 8. And this is the same thing as 8. So we'll rationalize the fraction by the 5th root of 8 raised to the power 4 over the 5th root of 8 raised to the power 4. So this would give us 4 multiplied with the fifth root of 8 cubed. 8 cubed is 4096 over, here we have 8. If we simplify it and reduce it to its lowest term, 4 divided by 4, 1. 8 divided by 4, we have 2. So we have the fifth root of 4096 over 2. So let's talk about fractions with denominators that are binomial. So let's take this question. We have 3 over 5 plus root 2. So yeah, the denominator of this fraction is a binomial expression. So how do we rationalize this? Yeah, we don't multiply by root 2 over root 2. No. This is going to give us 3 root 2 over 5 root 2 plus 2. We are still going to have a surd in its denominator. So we have not achieved the purpose of rationalization. So what are we going to do if we can't do this? What we are going to do is that we multiply by its conjugate. The conjugate of this denominator is everything here and the opposite of its sign. The opposite of the opposite of plus is minus. So the opposite of plus here is minus. So this is the conjugate of 5 plus root 2. So the conjugate of 5 plus root 2 is 5 minus root 2. So 5 minus root 2. Let us multiply the numerator. 3 multiplied by 5 is 15. 3 multiplied by root 2 is 3 root 2. 3 root 2 over, we have 5 plus root 2 multiplied by 5 minus root 2. You should be familiar with this. A minus B multiplied by A plus B is the same thing as A squared minus B squared. So our A is 5, our B is root 2. 5 squared is 25 minus B squared, root 2 squared. Root 2 multiplied by root 2 is 2. So we have 15 minus 3 root 2 over 23. So this is the rationalization of this. We can see that we have a rational number as its denominator. Let's take another similar question. Let's take 6 plus root 3 over root 3 minus 2. So as I said earlier, the conjugate of this is everything there except the opposite of its sign. So we have plus 2 over root 3 plus 2. So if we should simplify this, we have 6 multiplied by root 3, we have 6 root 3. 6 multiplied by 2, we have 12. Root 3 multiplied by root 3, we have 3. Root 3 multiplied by 2, we have 2 root 3 over, yeah, root 3 minus 2 multiplied by root 3 plus 2. Here we have the same terms, just different signs. So our solution will be a squared minus b squared. So a squared root 3 squared, that is 3, minus b squared 2 squared, that is 4. So this should give us 6 root 3 plus 2 root 3, we have 8 root 3. 12 plus 3, we have 15. 3 minus 4, we have minus 1. So if we divide this by minus 1, we would have minus 8 root 3 minus 15. So this is basically everything you need to know about rationalizing denominators. If you want to rationalize numerators, we do the same thing also, just the same similar procedure. So if it was the numerator of this we want to rationalize, we just multiply by the conjugate of the numerator, that is 6 minus root 3 over 6 minus root 3. So that is rationalization. Hope you learned something from this video. If you have not subscribed, don't forget to hit the subscription button. See you next time. Bye.